Hey everyone, welcome back. Today we're going to walk through a classic algorithms problem, finding the minimum spanning tree, or MST, using Kruskal's algorithm. We're going to break down the graph, understand what nodes and edges are, explain what a spanning tree is, and then we'll write the Python code together using NetworkX to compute the MST automatically. So here's the problem. Here's the diagram, and here we see 6 vertices or nodes, A, B, C, D, E, F, and we see the edges associated with each of them. So, and the associated weights. So, for example, the edge from A to D, the weight is 2, and here's the edge. So our goal is to select a subset of these edges such that all the nodes are connected, there are no cycles, and the total cost is minimum. This structure is called a minimum spanning tree. So before we run the algorithm, let's clarify a few important concepts. So what are nodes? So nodes are also called vertices, which are the points in the graph. Here they're just letters, so A, B, C, D, E, F, and edges are the lines connecting these nodes. So what is a spanning tree? A spanning tree is a set of edges that connects all nodes without forming any loops, and with exactly n-1 edges for n nodes. So loops is when an edge goes from start to finish. So a loop could be, there could be a single loop on, for example, D, and it would just loops around. So what is Kruskal's algorithm? It's an algorithm that builds the MST by sorting all the edges by weight, adding the smallest degree first, skipping edges that form a cycle, which I just mentioned before, and it continues until all nodes are connected. And that's what we're going to use the Python package NetworkX. That's what it's going to allow us to do. So to break it down further, here's the problem. So it shows left hand, right side, and each of these edges has the following weights associated with them. And the goal is to find the set of edges in the MST. And now we'll write the Python code to get us there. So here we write so we're going to import the Python package NetworkX as nk, nx. G is equal to nx.graph. That creates an empty graph. Now we're going to create the edges. So we're going to create, each row is going to have the node, the initial node, where it's going, and then the weight associated with that in a tuple. So it goes from node A to node D, and the weight is 2. So I'm going to copy and paste this for as many edges that we have. So AD 1, 2, 3, 4, 5, 6, 7, 8, 9. So just replace the values. AE is 7. AF 14. is 12. Okay, so now we have this. Close that. Okay, so we created the graph, we created the edges, and then we did add weighted edges from, which loads all of these into the graph right here. Now, nx.minimum spanning tree runs Kruskal's algorithm internally and returns a new graph containing only the edges in the MST. And then here we create a list because listing the edges shows exactly which ones were chosen. So let's run this. And here we get the edge A to D, D to C, E to C, E to B, F to B. And these are weighted accordingly right here. So if you add up all these weights, it's going to be 20. So 2 plus 6, 8 plus 3, 11, plus 5, 16, plus 4 is 20. And that's how we use Kruskal's algorithm in Python to compute the minimum spanning tree for this weighted graph. We talked about what nodes are, what edges are, what cycles are, what a spanning tree means, and why Kruskal's algorithm is perfect for this kind of problem. Thanks for watching, and I'll see you in the next one.